Okay, let's see how we can apply our special triangles. So it says sine theta equals 1/2. Do a better theta. Now it says between 0 and 360 again. Remember, be careful with that. English instruction is there. So let's draw a graph. An ASTC graph. And look above, sine's positive. So sine's positive where they're all positive in the A quadrant and in the S quadrant where only sine's positive. And I don't care. I just draw a couple big triangles in those quadrants. Now, the sine ratio from above, sine theta equals opposite over hypotenuse. So we label the opposites of theta and the hypotenuse and the opposite and the hypotenuse. Remember, theta is always at the origin, never the wings. Okay, so sine theta equals 1/2. So following the instructions on the right-hand side, draw two triangles where sine theta is positive, or whichever case it is for whichever question you're doing. Label the triangles according to SOHCAHTOA. Now label the reference angles according to special triangles. So I'm going to take one of these triangles off to the right and write it in exactly the same orientation as you see it and label it 1 and 2 and try and remember what the sides were. Well, we remember that this was our equilateral triangle cut in half, and the 60 opens up to the root 3, and the 1 is therefore 30. So we can put 30 in both locations. If you want to skip that step and draw everything in the diagram, you can, but eventually we're not going to need that stuff, so you can just kind of like skim the stuff on the right. Okay, so we know the reference angles are 30s, so now draw an arrow from the principal axis to both of our terminal arms and find out what theta STP is. So theta STP is equal to, in the first quadrant, it's 30 degrees. And then the second quadrant, well, we can mark 0 and 180. And we know that we're just 30 short of 180, and 180 minus 30 is 150 down below. Circle your answer, type it in. So the question says sine theta. Theta is 30 and 150. So type sine of 30. You better get 0.5, like the question's answer says. 1/2 equal to 0.5. So our first answer, 30, is good. Now let's try the other one. Sine 150. Also 0.5. Check mark. Both of our answers are good. Seen on a graph. Well, this is the graph of y equals sine theta. We're going to graph it later in the chapter. Sine theta goes up to 1 and down to -1. Therefore, when is the graph sine theta equal to 1/2? Right here, about at 30 degrees and 150 degrees. Right before 180, finishing a perfect cycle at 360. Sine theta is equal to the graph 1/2 at two locations, when theta is 30 and 150. So when you're sitting on the Ferris wheel and you got that triangle following you around, you can predict where you'll be in a year from now, kind of like we can do with the moon. Fun. Okay, this next one, let's shrink that up a bit. And put a line between it and write the next question. So cos theta equals -1/√2. Well, let's start with our ASTC graph. So 3 vertical lines, 3 horizontal lines. ASTC. Well, cosine is negative, and it's positive where they're all positive and where only cos is positive, so not there. In the S and the T quadrant, where cos is negative in both of those. But now we're working with cosine, and from grade 10 we learned SOHCAHTOA, where cosine is equal to adjacent over hypotenuse. So we can label the diagram with an adjacent of 1 and a hypotenuse of 2. If you want to call those ones negative, do it. But I like ASTC. So now I'm going to draw one of those triangles off to the right in exactly the same orientation. I'm going to do the rest in black. Put my 90-degree in. Put my hypotenuse. Excuse me. Oh my gosh. Okay, I'm changing the question a tad. Cos theta equals negative 1 over root 2. Therefore, the hypotenuses in the diagram are root 2. Again, I changed the question to be cos theta equals negative 1 over root 2. Again, I changed the hypotenuses to be root 2. So we have root 2, and we have adjacents of 1. Well, we know from special triangles that's the 1, 1, root 2 triangle, and it's isosceles with both angles that are 45. So I can put 45 in the diagram in both locations. Theta reference is 45, and the only grown-up angle that we care about is theta STP, which is equal to the angle from the positive x-axis to both terminal arms. So I'm going to draw those in. Now, the first one is just 180 minus 45, which is 135. And the other is 180 plus 45, which is 225. Circle our answer. Take a look at the notes and see how I check those answers, typing in the answers back in. Now, cos 135 is equal to negative 0. I'm going to write that down at the bottom right. I'm going to check that you can see this. Equals negative 0.707. Well, is that correct? Well, let's type in the question. Negative 1 over root 2. Negative 1 over root 2 is also negative 0.707. So because they're equal, we know we did it correct. Now, as you can see in the notes, I gave a general solution for this example like I did in two sections ago. And I also drew the graph to show that the cos graph goes on forever and ever. We're just graphing, going around a Ferris wheel forever and ever and ever. And that's why we have general solutions with multiple answers where we simply just add 360 and add 360, add 360 and add 360, or subtract. Always check your answer. So, it might be tan. It might be negative sine, reviewing this whole page. Well, either way, follow the English instructions on the page at the top right-hand corner. Draw two triangles where sine, cosine, or tangent is positive or negative. Label the triangles according to SOHCAHTOA. Label the reference angles according to special triangles. Draw an arrow from the principal axis to the first terminal arm. Draw an arrow from the principal axis to the second terminal arm. Solve for theta STP and check the answer on the calculator. Use sine, cos, or tan. ASTC to decide whether they're positive or negative. Be careful with your special triangles.